Section 5.2 is on medians and altitudes of triangles. A median is a segment whose endpoints are a vertex and the midpoint of the opposite side. So here in triangle ABC, we have segment AM, which is a median, and it's a median because it goes from a vertex of the triangle, which is A, over to the midpoint of the side that is opposite. M is the midpoint of side BC, and you can note that by the two little pink marks here. So since AM is a median of triangle ABC, CM is congruent to MB. Since a triangle has three vertices, it also has three medians. The point where the three medians intersect is called the centroid, and in this case that would be point P. You can see that from each vertex there is a segment that goes to the midpoint of the opposite side. So that would be AK, BL, and CJ. So the centroid theorem says that the centroid of a triangle is 2/3 of the distance from each vertex to the midpoint of the opposite side. So given median AK here, AP, the length of AP, is 2/3 of the length of the whole median. Given median BL, the length of BP is 2/3 of the length of BL, and given median CJ, CP is 2/3 the length of the whole median CJ. An altitude of a triangle is a segment that goes from a vertex and it is perpendicular to the opposite side. If you're at all familiar with, perhaps from pre-algebra, doing the area of a triangle, this is the segment that represents the height of the triangle. It goes from a vertex, in this case C, and it is perpendicular to the opposite side, AB. And notice we can tell that it's perpendicular because we have this little pink box in the corner. So segment CD is an altitude of triangle ABC. And since a triangle has three vertices, it also has three altitudes. And the point where the three altitudes intersect is called the orthocenter. So in this triangle, point P is the orthocenter, and it has no theorem. Let's take a look at a couple examples here. So given triangle ABC, we need to find the length of segment BC if AD is an altitude of triangle ABC. Well, if AD is an altitude, then that means that this is perpendicular. AD is perpendicular to BC. And that means that this angle, angle ADB, and also angle ADC, are right angles or measure 90 degrees. So I can say 4x plus 10 equals 90. Subtracting 10 from both sides, 4x equals 80, or x equals 20. Now, in order to find the length of segment BC, notice that BC is made up of BD and DC. So that's 2x plus 3x minus 4. And substituting in 20 for x, I get 40 plus 60 minus 4, or the length of segment BC is 96 units. Second example says, find the length of AB if BD is a median of triangle ABC. Well, if BD is a median, then D has to be the midpoint of AC, because remember, a median goes from a vertex and to the midpoint of the opposite side. So AD has to be equal to DC. So AD equals DC, and I'll use this to find x. X plus 3 equals 2x minus 17. And subtracting x on both sides and adding 17, x is equal to 20. Notice the length of segment AB, which is what we have to find, is x minus 7, or 20 minus 7, so the length of segment AB is 13 units. So a median goes from a vertex to the midpoint of the opposite side. An altitude goes from a vertex and is perpendicular to the opposite side.